limit x tends to 8 cube root of x minus 2 divided by x minus 8. So if we directly put x is equal to 8 in the square root of x, then what we have in the numerator, like if we put x is equal to 8, then this is going to be 2, and 2 minus 2 is 0. So in numerator what we have 0. Now we are going to talk about the denominator. There is a x minus 8 term. So if we put x is equal to 8, then this is going to be 8 minus 8 is 0. So finally this is a 0 by 0 form, and here what we can use the substitution method. Let me change the color. This is what the substitution method. But we try to solve this limit with the help of the factoring method. So with the help of factoring method, what we will do, this term, try to change x minus 8 as a multiple of cube root of x minus 2. Let's see how we are going to make it. Then limit x tends to 8, and in the numerator what we have cube root of x minus 2, and in denominator we are going to write cube root of x. We try to cancel the numerator term here. So because finally we are getting the 0 by 0 form, that's why. So it's cube root of x minus 2. So this term and this term will be cancelled, but we need to balance out this function. So what we gonna write here, cube root of x square, yes, and plus 2 cube root of, just I'm trying to make it as a multiple of x, and finally which is going to equal as a x minus 8. So yeah, plus 4. So what we have finally, as a, we are going to cancel this term first. This term and this term is going to cancel, and finally we have 1 upon cube root of x square plus 2 cube root of x plus 4. So now what we are gonna do here, we just put x is equal to 8. Then if we put x is equal to 8, then in denominator there is a square term. Then the first term, I'm talking about the first term. Let me show you this first term. This is going to 8 power 2 is going to 64, and because of the cube root we have 4 here. Yes, and if we talk about here, then 8 is going to be 2 into 2, here again 4, then 4. Then what we have finally, 1 by 12. This is the answer for this limit. This is going to be the E part. Let me solve the another problem. The problem is like this is going to be if limit h tends to 0, 1 upon x plus h minus 1 upon x upon h. So if we put h is equal to 0 in denominator, then what we have, denominator we have 0. And if we talk about numerator, in numerator there is a h term, yes, and that h term is going to 0, and the after putting 0 at the place of h, this term is going to 1 upon x, and this term is going to 1 upon x, and this is also the 1 upon x. This is going to be cancel out. So this is 0 upon 0 term. So this is what the, this is the indeterminate form. This is the indeterminate form. Let's try to solve with the help of the factoring method. What we do actually, we try to multiply the numerator term. H tends to 0. We just want to cancel out the h term. Okay, so 1 upon, this is in numerator we have h. If we multiply these both terms, so in denominator what we have, the x plus h and x, and divided by h, then this h term is going to cancel, and finally what we have, 1 upon x plus h x, and if we put h is equal to 0, we know, we try to put h is equal to 0, so this is going to be x square minus x square. But actually let me show you, this is a best problem, because this is showing the, this is equivalent to the derivation formula. Let me show you how is it equal to the derivation formula. So in derivation formula what we have, in derivation formula, if fx is equal to 1 upon x, yes, and if we want to take the derivative of fx, function fx, then we have f dash x, and here that is equivalent to limit h tends to 0, and limit function is going to f x plus h, and minus f of x divided by h. So if we put h is equal to 0 in denominator, the whole term is, this is the actually the definition. This is equivalent to, if we see, this is showing the derivative of this limit is actually showing the derivative of that. Like if there is a function is equal to 1 upon x, that function's value is going to be minus 1 upon x square if we take the derivative of that function. So this is the best problem to understand the derivation formula, how is it working, and how we can solve with the help of the limit problem.